All right, we are working on probability. So the probability is always going to be a fraction, and it's a ratio of total outcomes to preferred event that you're interested in, which references the first question. Distinguish between an outcome and an event in probability. And so outcomes are the basic possible results of observations or experiments. An event consists of one or more outcomes that share a property of interest. So I'm going to be asking for the event that I like out of the total number of possibilities. Give an example in which the same event can occur through two or more outcomes. Suppose you roll a fair six-sided die. The possible outcomes are rolling 1, 2, 3, 4, 5, or 6. The event of rolling an even number will occur with the three outcomes 2, 4, or 6. The same event can occur through two or more outcomes. Briefly describe the difference between theoretical, relative, and subjective techniques for finding probabilities. So theoretical is when you think that all the events, so something random happens, and so if something random happens, then you're thinking that for the theoretical probability that all the events have the same likelihood of happening, right? So for the relative, it's that the theoretical technique is based on the assumption that all outcomes are equally likely. The relative technique is based on observations or experiments. So the relative is you're looking at a bunch of data and you're deciding what the probability is based on data or experiments. Subjective is based on experience or intuition. So the subjective one is usually given by a person. The relative one is usually given by a scientist who knows some data, and the theoretical technique is given by using some mathematics. Which of the following is an example of a theoretical probability? The probability of rolling a 3 on a single die. Well, a die has 6 sides. The probability of rolling a 3, that's one way of rolling a 3 out of 6. That is a theoretical probability. Which one of the following is an example of a relative frequency probability? Oh, I'm liking this one. Based on statistical data, the challenge of having the championship team coming from the Eastern Conference of a certain basketball league is about 1 in 10 based on data. Which of the following is an example of a subjective probability? Probability of baby not being born, the odds of rolling a 3, the probability of landing on heads when tossing a coin. My teacher assures me that he is certain 100%, or probability 1, that my SAT scores will be the highest in the entire country. That is completely subjective. What is the probability distribution? So after class today, I'm going to do something like this, right? So what am I going to do afterwards, after I leave class? So I'll leave class, right? 30% of the time I'm going to go home, right? 40% of the time I'm going to go to Kroger. 10% of the time I'm going to go to the gym, right? And then 20% of the time I'm going to see a friend. So this is a probability distribution of what I'm going to do when I leave class tonight, right? What makes it a probability distribution is that all these numbers are probabilities and they add up to 100%. So a probability distribution represents the probabilities of all possible events of interest. Explain how to make a table of a probability distribution. Choose the correct answer below. To make a table of a probability distribution, list all possible outcomes, identify the outcomes that represent the same event, and then find the probability of each event. Decide whether the following statement makes sense, or is clearly true, or does not make sense, or is clearly false. Explain your reasoning. When I toss 4 coins, there are 6 possible outcomes that all represent the event of 2 heads and 2 tails. Let's see that. Toss 4 coins. So let's see if that makes sense. Well, we got to get a new page here. Let's get a new page. It's 1, 2. I'm going to toss 4 coins. So 2 heads and 2 tails. So 4 tosses. 1, 2, 3, 4, 5, 6, 7. We'll do one more. 3, 4. Okay, so we can do this, right? So we can have heads, 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 right? All heads, and then I'll throw tails in here. I'll throw 1 tails in here. There are 4 ways to throw tails in here. We'll use that later. And then so that's all with 1 tails, right? And then now we need 2 tails. So we'll put both here. We'll put 1 here, and we'll move it. And then we will put them both in the middle, maybe. That. Right, and then what we'll do is we will then switch them, right? Because we could put them both at the end, right? So 1, 2, 3, 4, 5, 6, 7, 8. All right, and so then we can switch the heads and tails, right? So then we got tails, 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 tails. We got tails, heads, tails, tails. We've got heads, tails, tails, tails. We got tails, tails, heads, tails. We got tails, 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 heads. We've got heads, heads, tails, tails. We've got heads, tails, heads, tails. And then we've got tails, heads, heads, tails. All right, so that's all 16 ways. And now we're looking for the number of ways. I think we were here, right? Page 3. We need, they're claiming 6 different outcomes that all represent of 2 heads and 2 tails. Let's see, we'll change the color. We need 2 heads and 2 tails. 2 heads and 2 tails. 1, 2, 3, 4, 5, and 6. That is correct. The statement makes sense. There are 6 different ways the event can occur. Decide whether the following statement makes sense, or is clearly true, or does not make sense, or is clearly false. Explain your reasoning. The probability that I estimate that the probability of Mike getting married in the next 3 years is 0.7. That's perfectly fine. That's completely subjective. That's up to the person. Decide whether the following statement makes sense or is clearly true, or does not make sense or is clearly false. Explain your reasoning. The probability that Jonas will win the race is 0.6, and the probability that he will not win is 0.5. That does not make sense because the probability of winning plus the probability of losing, you can only do one or the other. It needs to be equal to 1. Either you win or lose, assuming there are no ties, right? So, and even if there are ties, that the point is that 0.6 plus 0.5 is more than 1, and so you can't have two probabilities of an event adding up to more than 100%, and so this does not make sense. The statement does not make sense because the sum of the probabilities of Jonas winning and losing, winning and not winning the race must equal 1. How many different choices of car does a person have if a particular model has 11 colors and 4 styles? Right, so there's a rule here that you multiply, so that if you have a couple of categories, one category that has M items and another category that has N items, then the total number of categories with both items is you multiply M times N. So this is called the MN rule, and it extends that if you have 3 or 4 items, you just multiply the number for the total number of combinations. Answer is 44. Pizza House offers 3 different salads, 5 kinds of pizza, 6 desserts. How many different 3-course meals? We'll just multiply. 6 times 5 is 30, times 3 is 90. Suppose we describe the weather as is either windy or cold. Answer parts A and B below. Using the letters W and C, list all possible outcomes for the weather on 2 consecutive days. Well, it could be windy on one day, cold on the next. Windy on one day, windy the next day. Cold on one day, windy the next day, or cold on both days. Right, so you would just put those, separate with a comma. If we are only interested in the number of windy days, what are the possible events for 2 consecutive days? The number of windy days. Well, you could have 0 windy days in this case. You could have 1 windy day in this case or this case. Or you can have 2 windy days. So the events are 0, 1, 2, whole numbers. Use the theoretical method to determine the probability of the following outcome and event. State any assumptions made. Tossing 2 coins and getting either 1 head or 2 tails. Right, so I'm going to toss 2 coins. So I could get both heads. I can get heads and the tails. I could get tails and the heads, or I could get both tails. Right? So there are 4 possible outcomes, and the events that I'm interested in, or means that either one. Right, so I'm just going to add these 2 things as long as they don't overlap. So, and these don't, because either I have a head or 2 heads. I can't have both at the same time. So 1 head would be here. That's 1. Another time in which event or outcome where I have only 1 head is this one. And then, or I wanted 2 heads. So this one. 3 out of 4. Assuming that the coin is fair, then and is equally likely to handle heads or tails, the probability is 3/4. An experiment consisting of drawing 1 card from a standard 52 card deck. What's the probability of drawing a king? Well, there are 52 cards. There are 4 kings. That just reduces to 1 out of 13. Determine the probability of having 1 girl and 3 boys in a 4-child family, assuming boys and girls are equally likely. So we can do this in all sorts of ways. So I'm going to do this in a couple of ways, right? So one way is we are going to say we've got 4. Well, let's get a new page. So I've got 1 girl, 3 boys, right? So I got 1, 2, 3, 4. How many ways can this happen? So if I list all the people in order, I can list them from youngest to oldest, or I can just put them in slots, right? So I can have girl, boy, boy, boy. I could have boy, girl, boy, boy. I could have boy, boy, girl, boy. Or I could have boy, 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 and then girl. Right? So this is 4 ways. The question is, out of what? The most important question in probability is, what is the denominator? Well, how many ways can you have children this way? Well, there are 4 children, right? And there are 2 ways in each instance that we could have had a kid, either a boy or a girl. And what the MN rule says that we just introduced is that, well, the total number of ways, the total number of combinations you could have is 2 times 2 times 2 times 2, which is 16. So there's 16 total ways. And we could have listed them out. 4 over 16 reduces to 1 over 4, which is the answer. We could have listed out all 16 ways, right, by doing what we did earlier with heads and tails, right? And so when we had heads and tails in 4 spaces, we had 16 total ways. We wrote them all out earlier. I believe it was right here, right? So if I just change this to boys and girls, it's the exact same thing, right? And if you're looking for, if we go back here and change this to boys and girls and did this the long way, we're looking for, let's say, 1 heads and 3 tails, right? Then that would be 1 head and 3 tails. That would be over here. So that's 1, 2, 3, 4. 4 out of 16. Right. It's the same type of exercise. The answer is 1/4. Use the theoretical method to determine the probability of the following event. A randomly selected person has a birthday in February. February has 28 days. So there are 28 days. This person's birthday, we're hoping, is one of those 28 days out of 365, because it's not in a leap year. 28 out of 365. You run into another person and you both have birthdays in August. What's the probability that you have the same birthday? Well, that's another way of saying that you have your birthday in August, and what's the probability that they match your birthday? Their birthday is also in August, so there are 31 days in August, and that person has to have your birthday. 31. The local weather forecast has been accurate for 16 of the past 37 days. That's a relative frequency probability that we're about to guess. And so we would use that data to surmise that moving forward, the probability that it's going to rain, the forecast for tomorrow will be accurate, is going to be 16 out of 37, just using the recent data. To the thousandth, that's 3 decimal places, 0.432. State which method, theoretical, relative, frequency, or subjective, should be used to answer the question below. All of these are going to be theoretical. What is the probability of being dealt a pair of 7s and a 5-card hand? We don't do this relatively. This is going to be completely theoretical. And the theoretical method should be used because the best approach to finding the probabilities to actually counting all the cards. What are we looking for? A pair of 7s, counting all the cards, counting all the possible hands with a pair of 7s. Determine the probability of a given opposite event. So if the probability, here's the issue about opposites, right? The probability of the opposite of E is 1 minus the probability of E, right? So if I'm going to go to the store 30% of the time, then the probability that I'm not going to the store is 70%, right? It's 100% minus the event. What's the probability of rolling a fair die and not getting an outcome less than 2? Well, the outcome that is less than 2 is getting a 1, right? So the probability of getting a 1 is 1 out of 6. So the probability of not getting an outcome less than 2, the probability of not getting a 1 is 1 minus 1 over 6, which is 5 over 6. So you find the probability of getting something that's less than 2, and then you do 1 minus that. Determine the probability of the given opposite event. What's the probability that a 47% free throw shooter will miss her next free throw? What does it mean to be a 47% free throw shooter? That means that they make it 47% of the time. So the probability that she will miss it is 100% minus 47%. So, and they want you to write it as a decimal. Right, so probabilities are decimal, so it's 0.53. So it's 53% that she'll miss, or 0.53 as a decimal. Decide which method, theoretical, relative, frequency, or subjective, is appropriate and compute. An experiment consisting of drawing 1 card from a standard 52 card deck. What's the probability of drawing a red 10? Well, there are 2 red 10s. There's the 10 of diamonds, and then there is the 10 of hearts. That's 2. Well, first of all, this is going to be the theoretical method. And this is 2 out of 52, which reduces to 1 out of 26. Decide which method, theoretical, relative, frequency, or subjective, is appropriate and compute or estimate the following probability. A card is drawn at random out of a well-shuffled deck of 52 cards. Find the probability of drawing an 8, 9, or 10. Well, there are 4 8s, 4 9s, and 4 10s, right? That's 12 out of 52. They're both divisible by 4. That is 3 out of 13. This, of course, is theoretical. Decide which method, theoretical, relative, or subjective, is appropriate and compute or estimate the following probability. Randomly meeting someone born between 3 and 5 p.m. This is still theoretical, and between 3 and 5, that's 2 hours of the day out of 24 hours. So that is going to be reduces to 1 out of 12. Decide which method is appropriate and compute or estimate the following probability. Randomly meeting someone with a phone number that ends in 5 or 6. Well, a phone number could end in the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. This is actually 10 numbers. So out of the 10 numbers, you want a 5 or a 6. Those are 2 numbers out of 10. That reduces to 1 out of 5. Use the theoretical method to determine the probability of the outcome or event below. The next president of the United States was born on a Wednesday. There are 7 days in the week. Wednesday is one of them. The probability is 1 out of 7. In a family with 3 children, excluding multiple births, what is the probability of having 3 girls? Assume that a girl is as likely as a boy at each birth. You can do this in a couple of ways. There's only one way to get 3 girls out of. Now we need to figure out how many ways can you have 3 children. Well, again, that's 1, 2, 3. You have 2 choices, boy or girl. 2 choices, boy or girl. 2 choices, boy or girl. And again, with these 3 numbers, you multiply. It's 2 times 2 times 2. That's 8. Or again, you can write out the possibilities. Boy, boy, boy. Girl, boy, boy. Boy, girl, boy, or boy, boy, girl, and then switch the boys and girls symbols. And then that gives you all 8. And so then this will be girl, boy, girl, and then girl, girl, boy. That is all 8. Or you can just multiply each possibility 1 way out of 8 total ways. Suppose that an urn contains 3 black marbles, 9 white marbles, and 8 green marbles for a total of 17 marbles. If one marble is selected, determine the probability that it's green. Well, that's 8 green marbles out of 17. Let me just make sure. I'm sorry, 20 out of 20. 8 out of 20, which reduces 4 goes in that goes 2 out of 5. Decide which method, theoretical, relative frequency, or subjective, is appropriate and compute or estimate the following probability. Randomly meeting someone whose social security number ends in the same digit as yours. So you have yours, and now there are 10 possibilities, and it needs to match your one way, right? So we're going to do the theoretical probability is that it's 1 out of 10. It simply needs to match yours. Decide which method is appropriate and compute or estimate the following probability. Rolling a sum of 8 when you roll 2 dice. We got 2 dice. So again, the question is, what is the denominator? This is out of what? You need to get, so there's 6 choices for the first die, and there's 6 choices for the second die. So the total number of possibilities, numbers you're going to see are 36. We need to get an 8. How do you get an 8? So you can get an 8 by doing a 2 and a 6. You can get a 6 and a 2, a 3 and a 5 and a 3, and a 4 and a 4. That's 1, 2, 3, 4. That is 5 ways out of 36. And of course, this is theoretical. You are required to take 5 courses, 1 each in humanities, sociology, science, math, and music. You have a choice of 5 humanities courses, 3 sociology courses, 5 science courses, 3 math courses, and 8 music courses. How many different sets of 5 courses are possible if you have to pick one from each is the assumption. We'll go ahead. The lesson today that we're learning is that we multiply these numbers. 5 times 3 times 5 times 3 times 8. 1,800 different possibilities. A person can order a new car with a choice of 8 possible colors, with or without air conditioning, with or without an automatic transmission, and with or without power windows, and with or without a CD player. And how many different ways can a new car be ordered with regard to these options? Let's see what this turns out to be. Looks like it's 8 times 2 times 2 times 2 times 2, 128. The following table gives the gender and political affiliation of 100 randomly selected voters at a voting site. Suppose you select a voter at random from the voting site. Answer the following questions, A through E. What's the probability that you select a woman? I just need all the women here. Looks like 49 plus another 5 is 54 out of 100. That reduces to 27 out of 50. What's the probability that you select a Republican? How many Republicans are we talking about? Well, we got 24 of these, 26 of this. That looks like 50 out of 100, which of course reduces to 1 out of 2. What's the probability that you do not, let's erase some of this. What's the probability that you do not select an independent? Well, this do not means that we have the ability to subtract by 1, right? So here are the independents, the 12 independents, which means that there are 88 people who are not dependents. So that's 88 out of 100. So that's 44 out of 50. We can go even further. That's 22 out of 25. Not a dependent, so find the dependents and then subtract 1 from them. What's the probability that you select a female Republican? Female Republican. So that should be Republican female 24 out of 25. Just reduce, I'm sorry, 24 out of 100. Divide by 4. That looks like 6 out of 25. What's the probability that you select someone who is not a male independent? Where are the male independents? Male independents, men dependents, 7. So that means there are 93 out of 100 people who are not that. 93 out of 100. In 2010, there were 36 million people over 65 out of a population of 319 million. By 2050, it is estimated there will be 91 million people over 65 out of a population of 444. Would your chances of meeting a person over 65 at random be greater in 2010 or 2050? All right, so we're just trying to check which one's larger. Let's do this. 36 out of 319. How many decimal places are we rounding to the nearest thousand? 3 decimal places. 0.113. So 0.113, and 91 out of 444. 91 out of 444 is 0.205. 2050 is the answer, so 2050 is 0.205. Choose the best answer to the following question. Explain your reasoning with one or more complete sentences. Suppose you toss one coin 3 times in a row and get heads, tails, heads. If you are interested in the number of heads that appear, which of the following sets of 3 tosses has a different outcome but corresponds to the same event as the first set of tosses? So the event we're interested in is the number of heads that appear. Here there are 2 that appear, so I'm interested in getting 2 again. And it looks like it's either this one or this one. HHT because it has the same number of heads and tails. I like it. HHT because it has 2 results in one kind and 1 result of the other. Actually, we're looking for 2 exact heads. Okay, so I'm liking D. Choose the best answer to the following question. Explain your reasoning with one or more complete sentences. A box contains 20 chocolates, but only 2 of them are dark chocolate that somebody likes. When it is said that the probability of drawing one of the dark chocolates at random is 0.1, what kind of probability is being stated? That is definitely theoretical, because what's the reason? We'll say because both the total and desired number of objects are known, right? So you're taking, it's 20, and you want 2 out of 10. I'm sorry, 2 out of 20 is 0.1, 1 out of 10. When one coin is tossed, the probability of landing heads is 1/2, assuming the coin is fair. What does this statement really mean? It means that if you threw this thing up 1,000 times, then you're going to get something close to 500. Not exactly 500, but something close. Right, so this one's close, but you can actually get 500. It's just unlikely. Choose the best answers of the following question, explaining your reasoning with one or more complete sentences. Suppose that 4 6-sided die are tossed. How many outcomes? So we've got 1, 2, 3, 4, 6 choices here, 6 choices here, 6 choices here, 6 choices here. We found out that by the MN rule, you just go ahead and multiply. That gives you the total number of possibilities. A group of friends are playing 5-card poker with a deck of 52 cards. For a probability distribution showing the individual probabilities of all possible hands, what would be the sum of all the individual probabilities? It needs to be 100%, which is 1. The sum would equal 1 because the sum of the probabilities of all possible events in any situation needs to be 1. Hope it helps.